Hello everyone, welcome to the third and last part of our discussion with pointers. In this part, we are going to see how a one-day array can be passed to a function and how to realize a 2D array using the pointer. The second part of discussion will be in preliminary level. So passing an one-day array to a function, while passing an entire array, the array name and the numbers of elements present in that array are to be passed. In C language does not perform any bound checking, so the number of array present in that array that is necessary to be passed. While passing the array to a function, the formal argument can be an array or an pointer, which will hold the base address of the array we are passing. So, if A is an array of integer, in the formal argument either we can declare an array or we can use a integer pointer to store the base address of that array. So we are going to explain that with an example. Here you can see that in this example we have declared two functions. One is disp, another one is show. Both of them function its return type is void, so they are not going to return anything. And in the disp function, here we are mentioning that we are going to pass an integer type of array. And the second parameter is a simple integer. Now in case of show function, here we are mentioning that we are going to pass a address, integer type of address of an integer type. Now the second parameter is integer. Now in the main function we have declared an array A with 5 elements and we have initialized that array A with 10, 20, 30, 40 and 50. Then in that we are making a call to the disp function. And as we know, while passing an entire array to a function, we should pass the array name because array name is the base address. So here we are passing the base address as well as the number of element present in that array. In this case, the number of array present in this array is 5. So we are passing 5. Suppose the array size is 5, but the total numbers of array in that array is 3, then we are going to pass 3. Next, we are calling the show function with the same parameter, that is the array name and the number of element present in that array. Now come to the disp function. In the disp function declaration, we have mentioned that we are going to pass a one-dimensional array. So here X is the one-dimensional array. So X is the array where we are passing the A array. Actually, the total A array will not be passed. X as an array, it is of integer type. So basically, it is a pointer which will hold the address of A. That's it. The total entire A will not be passed. Now, the n is the number of element we are passing, that is 5. So, I is a variable I have declared and it will print in display. What it will print? It will print all the element present in X. So, this is an X is an array and by this loop we are printing all the element present in the array X. And what is present in array X? Actually, X is holding the address of A. That is why it is printing all the elements in, it will print all the element present in A. Now in the second function, that is in the show function, we are not passing or we are not holding the array name as in an array, we are putting it in a integer type of pointer which is X. So X is equals to A, and we know that if P is holding the address of an array, base address of an array, then each and every element of that array can be retrieved or can be accessed through this notation. So here what we are doing. So X is holding the base address of that array. So x plus I will give me the base at it will give me the address of the ith cell of that array, and x plus I whole star will give me value at the address given by x plus I. So by this incrementing the I value number in numbers of time, we are actually printing the total number of we are actually printing the array elements. Which array element? As x is holding the address of A, that is why it will print all the elements in A. So let us run this code and see what output we are getting. So you can see that the disp function is giving me all the elements of A, and show function is also giving me all the elements of the array. In this way, we can pass an entire one-dimensional array to a function. Now, let us see how a pointer will work with some other operator. Mainly, we are going to discuss about the pre-increment and post-increment operator. So let us take this first example. So you can see that A is an array of five integers having the value 10, 20, 30, 40 and 50. So this is my A. And X is a pointer of integer type. We are putting the base address of the array A into X. So if the base address is 1000, so X value is 1000, because base address of one-dimensional array is address of the A0 cell. Here the address of the A0 cell is 1000. Then we are printing the x plus 1 whole star and x star plus 1, these two value. So let us take what will be the output of this one. So as we know that the C follow right to left function calling, so this direction the parameter will be passed to the printf function. So it will first calculate this value. So what will be the calculated value? X star means, in this case x star means x value is 1000. So x star means star 1000 means the value present in the 1000 address, and it is 10. So x star will give me 10, and we are adding 1 to it, so it will be 11. So this %d will give me 11. Now the next parameter is x plus 1 star. So as x is holding the address of A, so x plus 1 star, we can say that it is equivalent to A1. And what is the value present in A1? It is 20. So in this format specifier of %d, we are going to get 20. So this printf statement will give me an output which is 20 and 11. Now let us come to this example. Here the same array has been used with the same pointer, and x is holding the address of A. Now you can see that here we have used the post increment operator. So, and with that we are using also the value and the address operator. Here it will act, and as we know in C, it follows right to left calling convention. So this parameter will be passed from in this direction. Concentrate on this term star x plus plus. What will happen over here? You can see there are two operators are there. One is asterisk and another one is post increment operator. Now as we know that post increment have the higher precedence than the asterisk operator, that is the value at the address operator. So plus plus post increment operator will act first on the operand x. Now what will happen over here? It says that the post increment nature, it says that it will first use the value of x, then it will be incremented. So it will first use the value of x. What is the current value of x? Considering the base address of the array is 1000, so current value of x is also 1000 for this statement. Now, as the value of x is 1000, so what it will get in the asterisk operator? It will get asterisk 1000. So this means value at the address 1000. So what is the value at the address 1000? It is 10. So this format specifier will print 10 for this parameter. Next, what will happen? Then the plus plus operator does not complete its work. It has been used. The value of x has been used. Now it will increment the value of x. So x will become x plus 1, and plus 1, as x is a pointer and we are considering integer is of 4 bytes, so x plus 1 will give me 1004. So now my current x value is 1004. Now in this case the x value will be 1004, and asterisk of x means value at the address 1004. So what is the value at the address in 1004? It is 20. So this print this parameter will give me 20, which will be printed in this format specifier. So for this code, the output will be 2010. Next, take another example. Here, instead of post increment operator, we are using the pre-increment operator. Now, here what will happen? The rest of the code is similar to the previous one, but we are printing the value of a1. That is this is the only, there is only difference in the printed statement. So x is equals to a, and considering the base address as 1000, so x value will be 1000. The pre-increment operator plus plus is with the operand x. So here what will happen? This will be evaluated as x equals to x plus 1, then then it will be x star. So x equals to x plus 1, that will be done first. So this will give me 1004. We have already discussed it. And then the asterisk x means value at the address x, that is 1004. Value at the address 1004. What is that value? That is 20. Right? So this parameter will give me 20, and it will be printed for this under this format specifier. Now, what is the value of x1? What is the value of a1? A1 value is 20, so it will become 20, and so this will give me 20 in this position. Right? So output of this code will be 20, 20. Come to this example. Here the printf statement is different, but the assignments are same. So considering x equals to 1000, as a's base address is 1000, so here what will happen? The asterisk operator is with x, then the plus plus or the pre-increment operator. So this will be evaluated as asterisk x equals to asterisk x plus 1, because pre-increment means increment the value. Which value? It will increment the value of this, then it is going to use the value. So this will be similar to writing asterisk 1000 equals to asterisk 1000 plus 1. Now asterisk 1000 means value at the address 1000, that is 10, plus 1, that is 11. So this 11 value will be stored in which address? In the 1000 address. So Here the array element, the value at the A0 cell will be modified and it will give me 11, and it will be modified to 11 because of this statement. So this will give me 11 and value of A0, which is now modified to 11. So it will become, it will give me 11. So output for this code is 11 11. Okay, so this is how the pointer operators will work with the pre-increment and the post-increment operator. Now, the question is why the pre-increment operator is working first? Because in the precedence table, it has the higher precedence than the asterisk operator. So, depending on the precedence, the operators are going to work with the value at the address of operator. Now let us see how can we define or how can we realize a two-dimensional array using pointer. So here we are declaring a two-dimensional array A and which have two rows and three columns. Now we are initializing that array A with the value 11, 12, 13, 11, 12, 13, 21, 22 and 23. Now though we consider that it is a two-dimensional array and we generally picture it like two rows and three columns having 11, 12 and 13 value in the first row and 22, 21, 22 and 23 value in the second row. In memory it is not put like that. It follows a contiguous memory allocation. So you can see that there will be 6 cells and each and every cells will hold a integer type of value. So each size of each and every cell will be of the size of integer. In this case, in our case, we are using a compiler which give me a 4 byte of space for integer. So each and every cell is of 4 byte. So let us take this is the A array and it initialize at the 1000 address. So from 1000 to 1003, that 4 byte will be for one cell. So the next cell will be from 1004. So the next cell will be from 1008. Then the next will be from 1012 and then the next will be from 1016 and the next will be from 1020. So these are the starting address of the all the 6 cells. Now in the first row there are 3 cells, means there are 3 columns. So first 3 columns on the first 3 cells will go into the 0th row and the next 3 columns will go into the first row. Now here we are going to actually, a two-dimensional array is basically a collection of one-dimensional array where each and every row is basically a one-dimensional array of same size. So the starting address of, in this case, the starting address of the 0th row will be similar to the starting address of the A00 cell, that is 1000, and the starting address of the first row will be similar to the starting address of the A10 cell, that is 1012. You can see that there are the two rows, the starting address of the two rows are apart by 12 bytes because each and every row will take 12 byte of space. The array name will always represent the base address or the starting address, but in case of two-dimensional array, the starting address or the base address means the starting address of the 0th row, not like one-dimensional array where the base address represents the address of the 0th cell. Here it represents the address of the 0th row. So array name, instead of represent a particular cell, it represents a row. So when we are adding an integer value to that array name, actually we are adding a row. So if I perform a plus I, then I am actually adding I numbers of row to the base address. So array name in case of two-dimensional array will give me the starting address of the zeroth row. So a plus I will give me the starting address of the ith row. Matrix A will give me the address of the zeroth row and zeroth column. How it is going to give me address of the zeroth row and zeroth column? Here the I value is 0 and then we are adding a 0, that is we are going to represent it as J. So A star is going to give me address of the zeroth row and zeroth column. Similarly, A plus I whole star we can write like A plus I whole star plus 0. So this will give me the address of the ith row and zeroth column where the column value is 0. So from there we can say that A plus I whole star plus J is going to give me the address of the zeroth row and jth column, which also can be represented by address of Aij. If we write this whole expression, if we put this whole thing and use a value at the address operator, that time it is going to give me the value of ith row and jth column, that is given by, that is actually the value of Aij cell. The value of Ij cell can also be retrieved using the notation A plus I whole star plus J whole star. So we can use any of the notation, but we generally prefer this one for simplicity. Next, we have already explained that this is how we are getting that one. So let us prove that using an example. Suppose we want to get the element present in A11 cell, right? And what is that value? In A11 we have 22. So if these two are equivalent, then we are going to get the value 22 when the I value is 1 and J value is 1 for this expression also. So we can write by putting the value of I and J, A plus 1 plus J. Now we know that A plus 1 whole star will give me the address of first row and zeroth column. Here I value is 1. So what is the address of first row and the zeroth column? The address of first row zeroth column is 1012. So this will give me 1012. Then we are adding the value of J to it. What is the value of J? That is 1. Adding 1 to it means 1 will be multiplied by the size of the data type. Here the size of the data type is integer. So as we are considering integer is taking 4 bytes of space, so 4 will be added to this one. So finally we will get 1012 plus 4, that is asterisk 1016. So what is the value at that 1016 address? We are getting 22. So you can see that in both of the cases we are getting the value 22. So we can say that Aij is equals to A plus I whole star plus J whole star. So another notation we can use to access each and every element of that array, and that notation is A, or the pointer to that array, two-dimensional array, plus the row number into that will be multiplied by the total number of column in each row plus J. So let us take, we want to find the value present in A12. So what is the value in A12? 23. So I, using this expression, I also get the value 23. And let us take how we are going to find that we are going to get that one. So A, that value is 1000. This is the base address plus I value is here 1. So 1, and what is the total number of column present in a row? There are 3 columns present in a row, so it will be multiplied by 3. Now plus j. What is the value of j? The value of j is 2. So that whole stuff. So what value I am getting? I am getting 1000 plus 3 plus 2 whole stuff. Now 1000 plus 5. Now this 5 will be multiplied by the size of integer because the array is of integer type. Here we are considering the integer size is 4 byte. So the 5 will be multiplied by 4. So we finally get 1000 plus 5 into 4, that is 1020, and as whole asterisk of this and whole asterisk of this will give me 23, so which we are expecting. So in this so you can see that we are being able to get the same value using this notation also. Now this notation will be useful for another kind of problem. Suppose for a two-dimensional array, the address of a cell is given to you, the array type is given to you, and you are given that how many columns will be there. You have to calculate the base address. Suppose for this A array, the memory is not like that. We need to calculate the base address. The address of A11 cell is 2040. Then we need to calculate the base address of the array. How we can calculate? Here the base address is unknown, but we know the value for this expression. So let us put the base address which is unknown. So a plus I value is 1. So 1 into total number of columns, suppose it is given 3. So into 3 plus 1 is 1040. Here we need to multiply this with the size of the data type. So this will give me a plus 4 into size of integer, as a is an integer type of array, equals to 2040. So this will give me a plus 16 equals to 2040, implies a equals to 2024. So the base address of the array is 2024. In this way, by knowing the address of a particular cell of two-dimensional array, we can calculate the base address of the array. Now, as we have proved that this expression and this expression and these expressions are equivalent, then we are going to represent a two-dimensional array with the help of a pointer. Now in this case, you can see that A array is of 2 rows and 3 columns. So each and every row is basically a one-dimensional array of 3 elements. The P is a simple integer pointer, whereas the PA is a pointer to an array of integer of 3 elements. So we can assign the address of the 0th row to the PA because their data type is same, right? Now if we can perform this one, we can replace the array name with the pointer to an array, what we have done over here. Similarly, P is an integer type of pointer which is holding the same value as A. Then we can replace A with P also. So finally, using this notation, we can access the array two-dimensional array elements with the help of pointer to an array, and using this notation we can access the elements of an two-dimensional array using a simple pointer. We are going to see that thing in an example by running a code. So in this code you can see that I have three functions. Now look at the code. Here we are declaring user defined function disp show and print. Now in the disp function we are passing the two-dimensional, we are going to pass the two-dimensional array as a two-dimensional array. Now when you are passing the two-dimensional array as in the array form, you must mention the total number of column per row in the declaration, otherwise it will throw an compilation error. The reason is that it will not be able to calculate the size of each and every row which is required to access the element. Similarly, when we are passing the array as a pointer to an array, that time also we must mention the total number of column in the row. And if in the for actual argument and the formal argument the numbers of column mismatch, then it is going to throw an error. Now in case of show, we are passing that array as a simple pointer. Here we are passing the three more arguments, while in case of disp and print we are passing only two arguments. The reason is that here we need to pass the not only how many rows, how many actual columns, but also the total number of columns present in that two-dimensional array. Now let us come to the main function. Here A is a two-dimensional array of 2 rows and 3 columns having the value 11, 12, 13, 11, 12, 13 in the first row, 21, 22, 23 in the second row. We are calling the disp function with the array name. So we are passing the address of the 0th row, and we are also passing the total numbers of row and the total numbers of column per row. Similarly, in show function, we are passing the address of the 0th row, then the total numbers of row, the numbers of column we are using, and the total numbers of column per row. And in case of print function, we are passing the 0th address of the 0th row, then the total numbers of row and the total numbers of column. Now the disp, it will be stored the array as in array two-dimensional array form, and as I have mentioned, the formal argument and the actual argument column number will match, otherwise it will throw an error, and we are printing each and every element using the array form. In case of the show function, here we are passing the two-dimensional array as a pure pointer, and we are calculating the using this formula, and we are getting that value using the asterisk operator or the value at the address operator. Finally, in print function we are passing the address of 0th row of the array A and storing into a pointer to an array X, and we are accessing the each and every element using this notation, which we have already discussed, or we have already established that they are basically same as writing A, I and J. So let us run this code. Now here you can see that the line number 4 is throwing an warning because it is expecting a pointer to an row, but we are mentioning a simple integer. It is a warning, so for the time being we can ignore it, and we will see that it is going to run properly or going to give me the content of the array. So you can see that we are getting in both all the three functions, we are getting the content of that array. So In this way, we can pass a two-dimensional array to a function and access them using by pointer to an array or a simple pointer or even in a matrix form. Whatever form you are comfortable with, you can use. So that's it for today's video. We are going to revisit the pointers while we are discussing the dynamic memory allocation, which have a huge application, and you are going to see clear how we can generate some space at the runtime. So till then, stay safe and see you in the next video where we are going to discuss about the preprocessors in C. Thank you and see you later.